Hello, I'm Daxing. We'll be talking about the quant assignment today that given to me, and I'm from C358. Yeah, so the first question is asked us to import the data in the file using either MS Excel or R. So for importing the file, I've used um, the from the web access. Yeah, it allows me to take the data from Olive and import into Excel. Yeah. So secondly, they also ask us to use appropriate measures for data description, identifying the region for north, south, east, west, and central with the best air quality according to the 5 month of data. So I'm using average for my first question because that average can calculate the total total PSI for the whole month for the north region and for other respective region. So for my for my average, I use equal average and use all my region that I given to find the first average. Then secondly, they also ask us to from the region identified the worst air quality, compute the daily maximum for the region and use a suitable chart or plot to show the pattern in the air quality on a daily basis. So by using that, I using the pivot table, which is allocated at the insert area. So uh, I I press the date and time to the region that I wanted all the way to the end, and I press the pivot table to give me my pivot table. Yeah. So for the pivot table, they only ask us for the date and the worst region that have the highest PSI. So the highest PSI is PSI West. So in order to change the to maximum PSI West, we must double click here and choose the word max. Yeah, as you can see, here are the PSI value for each day, the highest PSI value. So this is the flow chart that that are used for the highest PSI. So you just drag all your data and you insert the pivot chart to give us the pivot table. Okay, so for question 2, they ask us to construct a 95% confidence interval of the mean PSI reading for the 5 months from June to October 2013. Yeah. From the second question, we conduct the standard deviation for 5 months. So by using stdev.p, we can calculate the overall population for the region, and using the mean, which is equal to the average of the total region, we find out that the total region average is 31.42, and the total sample by using count is 16280. So for the 95% confidence interval, we must find the standard error. The standard error, which consists of the standard deviation square root the total sample in order to give us the standard error. And the z alpha over 2, we find it using equal norm dot s dot inverse of 0.975, because of the 95% confidence interval, you divide by 2, and using the divide by 2, you use 0.5 to minus the answer to get 0.495. So using the 0.495, we go to the z table, and we can clearly find that the z table shows 2.575 critical level, and the sampling error the um, is the multiplication of the z alpha and standard error, and the higher limit and lower limit uh, are also found using the 95% confidence interval. So now the question asks us to count the number of days where the PSI in Singapore of all regions exceeding the reading of 30 for the month of July and August compared to September and October. And by using COUNTIF, we can clearly find out that the number of days that the PSI exceeding 30 accurately, and to do for the respective dates too. So after we found it, we use the for the probability of the days where PSI exceeded 30 during July and August. I use the number of days that exceeded 30 in July and August, which is 13 plus 6 equals to 19, over the number of total days that um, July and August consist, which is 62, to find out the answer for the probability of July and August. I have done so for the probability of September and October and get the answer of 0.245901639. And they have indicate the level of significance to be one level of significance. So we clearly can write the 0.01 here and the critical value which I mentioned earlier. As the level of significance is 0.01, which is equal to 1% of the shaded region, it also means that the region of the unshaded region is 99%. So in order to find the critical value, I divided 99 by 2 to get 4.95%. And using 0.5 minus 4.95 in the z table, the critical value of 2.575 is shown. After finding the critical level, I'm going to find the test statistic by using a formula for two proportion. My null hypothesis is the test statistic equals to 0, and my alternate hypothesis is that the test statistic is not equals to 1. So I got the answer of test statistic of 0.752888399. Yeah, since my result of test statistic is less than is more than negative 2.575 and is smaller than 2.575, it does not meet in the rejection region. So for my answer, I can reject the hypothesis, the null hypothesis.